We are standing on the edge of a technological leap so massive, it's almost hard to wrap your head around it. It's a full-on revolution, and it's being powered by quantum computers. These are machines that run on the strange, wonderful rules of quantum physics. And believe me, they are set to completely redefine artificial intelligence as we know it.
And that right there is not an exaggeration. Seriously, think about the most powerful AI supercomputer you can imagine today. Well, the tech we're about to dive into could make that machine look like a pocket calculator from the 80s. The potential here is just staggering.
Because this isn't just about a simple upgrade or making things a little bit faster. No, this is a fundamental revolution in how we process information itself. We are truly entering what many are calling the next great tech revolution, a whole new era of computing.
So, what does this all mean for you and me? Well, over the next few minutes, we're going to break it all down. We'll look at how these incredible machines actually work, why they're basically the perfect partner for AI, and we'll get a real sense of just how close this future might actually be.
Okay, so to really get this, we have to go beyond the basics of how our current computers think. We need to leave behind that comfortable world of zeros and ones and step into the pretty mind-bending world of the quantum.
So, think about how your laptop or your phone works, right? It's all based on bits. And a bit is really just like a light switch. It's either on, which is a 1, or it's off, which is a 0. Simple. But a quantum bit, what we call a qubit, is more like a dimmer switch. It can be on, it can be off, or, and this is the wild part, it can be both on and off at the exact same time. This one little difference, it changes everything.
And that dimmer switch thing? It has a name, superposition. This is the magic trick that lets a single qubit hold way more information than a classical bit. By being in multiple states at once, a quantum computer can explore a huge number of possibilities all at the same time. That gives it an unbelievable advantage for certain types of problems.
But superposition is only half the story. The part that really breaks your brain is called entanglement. This is where two qubits become linked in this bizarre, wonderful way. Whatever you do to one, instantly, and I mean instantly, affects the other one, even if they're miles apart. This connection is what allows their processing power to grow exponentially. It's a computational force unlike anything we have ever built.
So we've got these incredible, kind of weird quantum ideas. But the big question is, what does this have to do with artificial intelligence? Well, let's connect the dots and see how this all translates to a smarter, faster AI.
The thing is, modern AI is just power hungry. It needs an insane amount of computational muscle to do its job. Things like sifting through massive data sets, solving ridiculously complex optimization problems, and finding tiny patterns that no human could ever spot. And honestly, our classical computers are starting to struggle to keep up.
And the payoff? It's just mind-blowing. An AI model that takes weeks to train on the best supercomputer we have today could, in theory, be trained in a matter of minutes on a quantum computer. It just completely changes the timescale.
And here's the really crucial part. This isn't just about doing the same things faster. No way. It's about unlocking entirely new ways of doing AI. We're talking about totally new kinds of models, like quantum neural networks that can process data and learn in ways that are just fundamentally more powerful than anything we have now.
And hey, this isn't science fiction. It's happening right now. Huge players like Google, IBM, and brilliant minds at places like MIT are already building and tinkering with these early quantum systems. They're pushing the boundaries every single day. But as exciting as all of this is, we've got to be realistic. The path to a true quantum future is amazing, but it's also incredibly difficult. The road ahead is, fragile.
There are some massive hurdles to overcome. First, there's something called decoherence. Basically, qubits are ridiculously sensitive. The tiniest vibration, the slightest change in temperature, and poof, they lose their quantum state and the calculation is ruined. Second, we don't have all the software yet. We're still trying to invent the quantum algorithms for most of the problems we actually want to solve. And third, the hardware itself is just a monumental engineering challenge to build and keep stable.
So what's the answer for now? It looks like a hybrid approach. Teams are building systems where classical computers do all the heavy lifting they're good at, and then they hand off the really tricky parts of the problem to a quantum processor. It's kind of the best of both worlds, and it's a really smart step forward.
And that really gets to the ultimate goal here. Look, quantum computers probably aren't going to replace your laptop anytime soon. The real aim is transformation.
It's about using this new power to accelerate breakthroughs in medicine, in material science, in data analysis, solving problems that today are simply impossible.
Which leaves us with this one final, pretty profound question. As we learn to compute using the fundamental rules of the universe itself, are we just building a faster computer? Or are we on the verge of creating a completely new kind of intelligence, one that's literally powered by the fabric of reality? It's something to think about.